Hey guys, I'm an intern from SIMMI Foundation and we work towards the benefit of mankind. Current aim is education for all. So what are we waiting for? Let's get started.
In this session, we shall discuss about polysaccharides and biomedical importance of carbohydrates. Polysaccharides are also called as glycans, and these are those sugars which yield more than 10 molecules of monosaccharides on their hydrolysis. The general formula for polysaccharides is C6H10O5 N times. This is the general formula for polysaccharides. Polysaccharides can be classified as homopolysaccharides or homoglycans and heteropolysaccharides or heteroglycans. Homoglycans are polymers of same monosaccharides units, whereas heteroglycans are polymers of different monosaccharide units or their derivatives. Examples of homoglycans are starch, glycogen, inulin, cellulose, dextrine, and dextran. An example of heteropolysaccharide is mucopolysaccharide, also called as glycosaminoglycans. Starch is the main storage polysaccharide in plants, and it is a polymer of alpha glucose consisting of two components: amylose, which is water soluble component and constitutes about 15 to 20% of starch, and the other component is amylopectin, which is water insoluble and constitutes the major portion of starch. Amylose is a long unbranched chain, and the individual glucose units are held together by carbon 1 and carbon 4 glycosidic linkage in amylose component of the starch. Whereas in amylopectin, which constitutes about 80 to 85% of starch, it is a branched chain, and the branching occurs at carbon 1 and carbon 6 of glycosidic linkage. Also, there is glycosidic linkage between carbon 1 and carbon 4 over here, but the branching occurs at carbon 1 and carbon 6 in amylopectin. Cellulose occurs exclusively in plants and is the major component or constituent of cell wall in plant cell. Cellulose is a straight chain polysaccharide composed of only beta D glucose units, and these units are joined together by glycosidic linkage between carbon 1 and carbon 4 of the second glucose unit. So this is a type of a homopolysaccharide or homoglycan. Moving on to the last part of this chapter, which is biomedical importance of carbohydrate. Carbohydrates are chief source of energy. They are constituents of compound lipids and conjugated proteins. The degradation product acts as promoters and catalysts. Certain carbohydrate derivatives are also used as drugs like cardiac glycosides or antibiotics. Lactose, a principal sugar of milk, is present in lactating mammary glands. Degradation products utilized for synthesis of other substances such as fatty acids, cholesterol, amino acids, etc. Constituents of mucopolysaccharides, which form the ground substance of mesenchymal tissues. So, carbohydrates are the constituents of mucopolysaccharides. Inherited deficiency of certain enzymes in metabolic pathway of different carbohydrates can cause diseases such as galactosemia, glycogen storage disease, GSDS, lactose intolerance, etc. Derangement of glucose metabolism is seen in diabetes mellitus. This is the end of the topic on carbohydrates.
Thank you very much for listening to me patiently, and please stay tuned for more such videos. Once again, thank you.